pastor across the U.S. increases as the size of the church increases. The graph above shows the average pastor salaries for various church sizes. You can clearly see the pattern, but nothing that we have done so far really fits that pattern as far as regressions, right? Because we have looked at exponentials, we have looked at quadratics, we have looked at cubics, quartics. None of those are really going to fit that pattern right there. But this does look a lot like a log graph that we have seen here. So today we're going to introduce that log regression. And it can be used for a lot of real-world scenarios. And you can kind of see how this would probably make sense, that this would actually happen in this case, especially if we throw out the mega church preachers that like have Lamborghinis and stuff like that, that always question their motives a little bit whenever I see something like that. Although not all pastors of big churches, they probably make more than pastors of tiny churches, but probably not all of them having Lamborghinis. There's a few out there. Especially if we throw those out, like especially considering that when you're looking at a church, this is not supposed to be a position that people get into for the money of it. Whether you're pastoring 100 people or 500 or 5,000, you're going to see a slight increase, but you shouldn't see it like taken off. Whereas it may be different with a company that's for profit, where you might see as the company gets bigger, you might see those CEO price, values going up in a different pattern than we're seeing here. The logarithmic function models are going to follow this form here, a plus b times the natural log of x, or a plus b times log x, where a and b are constants, depending on whether it's a natural log or just a log for that. So let's look at doing one of these by hand, and then we'll look at with the calculator as well. So let me pull the calculator up. Calculator. Oh. Okay. All right, so it says, use the data given to write two equations that can be used to find the values for the constants a and b in the expression for L of x. So this is a little like the exponentials, where they're asking you to do it by hand, or at least set up the equations by hand. So we know that this is the form of the equation, and they've given us 2 points here. So this is the point 2, 3, and we can plug those in for x and L of x. So the first equation would look like this. We'd have 3 equals 2, I'm sorry, not 2, don't put that there, a plus b natural log of 2. And the second would be 7 equals a plus b natural log of 7. No, 5. Sorry. I'm getting mixed up on all my numbers here. Okay, so these are a little bit harder to find a and b in this situation because both equations have an a and a b, and natural log of 2 and natural log of 5 are numbers. They don't go away. So what we're going to have to do here is use something we've used a couple times before, is we can use substitution for this. So if we solve one of these equations for a and then plug that into the other equation, then we can find those values. We can pick either one of these equations. It really does not matter which one. So if I pick that first one and I solve it for a, then I would need to subtract b natural log of 2 and I will get A equals 3 minus B natural log of 2. And because this is equal to A, I can plug it in up here for A in my other equation. And so I will have 7 equals 3 minus B natural log of 2 plus B natural log of 5 there. And we are trying to get the B's by themselves. But right now I've got 2 B's in this equation, right? Can I put those together? Yeah, our natural logs are different, so we can't just like say that's B natural log of 7. We can't just like add those together. But really, natural log of 2 and natural log of 5 are just numbers, right? So like, if it was calculator active, which this one's not, if it was calculator active, I could just type natural log of 2 plus natural log of 5 in, and I could add them together. But this one's not calculator active. So what I would do for this, first thing I would subtract this 3, because it's in the way. And I would have 4 equals negative B natural log of 2 plus B natural log of 5. And both of these have B's with them. So I would factor out a B. Okay, so we're taking a B out, which will give us negative natural log of 2 plus natural log of 5, which I am going to write this way. 4 equals B, we'll write natural log of 5 minus natural log of 2. Can I put those together? If I have subtraction, what divide? I can use division. So I'll have 4 equals B natural log of 5 halves, or 2.5 if you want to use a decimal. There. And then I'm trying to get that B by itself, so I'm going to divide both sides by natural log of 5 halves. Cancel it here. So my B is 4 divided by natural log of 5 halves. And that's pretty much going to be where you're going to have to leave this one. There's not really a lot you can do to change that there. So that's your B value. It's a number because, like, if I wanted to, I could go over here and type this into the calculator. 4 divided by natural log of 5 halves, and it's going to give me a decimal for that. So this is an answer. It sort of feels like it's not because it's still complicated, but it is. So now that we found B, what do we need to do? We need to find A, and we can just take B and plug it into one of these other equations to find A. So I would probably use that first one. We've got 3 equals, instead of, let's see, A is right here. We'll have B is 4 divided by natural log of 5 halves times the natural log of 2. And so that natural log of 2 is like just like a natural log of 2 over 1. So this is really 3 equals A plus 4 natural log of 2 divided by natural log of 5 halves. And I would need to subtract that over to the other side. So A is going to end up being 3 minus 4 natural log of 2 over natural log of 5 halves. And I think he would leave it like that, but I'm going to open up his key just to check to make sure he left it that way. Actually, he went ahead and did decimals, but Yeah, you pretty much have to just leave it that way. Okay, now let's look at using our calculator to do a regression for this. So your steps, I think, hold on. Yeah, use the regression capabilities of your calculator. So he did not put here on the directions, regression directions, and I didn't add them in because we've done a lot of these, right? It's going to be the same as what we've done before. It's just we're going to pick a different regression from the list. So first thing we need to do is put our data in. Where do I go for that? Stat, edit. So you're going to go here, clear out anything that you already have, and go ahead and type in those numbers. Okay, so once you get that data in, where do we go to get our regression? Stat, over to calc. And if we just kind of go down through here, which one do you think we should be using? No, yes, LN reg. The other one that seems like a reasonable option is this logistic. That is not it. It is LN reg. Okay, and we're going to tell it L1, L2. Let's store this in Y1 in case we need it later. So how to do Y1? Alpha trace. Y1. We're going to calculate. Okay. So it says we are supposed to find a logarithmic equation model for the data above of this form where P represents the church size and S is the average pastor salary in thousands of dollars. So doing this, we have gotten, why is it not letting me? There. Why is it not letting me write? So we will get, whenever they do this, use the variables that they use. So like S of P equals, and then we found the A and the B. So we got negative 91.542 plus B is 29.909 if we round to 3 places. And then we got natural log of P for that. Everybody good here? Okay. And then they ask us to use that model to predict the annual salary in thousands of dollars for a pastor whose church size is 500 people. What would we do for that? Table's an option. You can do that. You can do the graph and do alpha trace. The graph, you got to get your window right first on that one, which is not bad with this because you put data in. So that'll work. Essentially, you're just plugging in 500 for your X, right? So there's a lot of options. My favorite one is just to do alpha trace Y1 of 500. And just put that in that way. If you do, when you do that on the calculator. If it is a calculator problem, it is my understanding, you don't have to show any work for this. All you have to write, you need to write S of 500. Don't do Y1 of 500 because that is calculator notation. Not everybody has the same calculator, so they're not going to accept that. You're going to do S of 500 equals, and then just put what you get, 94.3295403. So that would be your answer. I would probably put 94,329.54 per year. This is in thousands of dollars, so it does say in thousands of dollars here, though, so I think you'd be okay just stopping with that decimal. But you do have a lot of other options. You can just plug in 500. You can look at it on the graph. You can look at it on the table. Those are all other options for that. All right, we're going to stop with this right now. I think that this is going to be a relatively easy section for us because it's really just doing the regression stuff we've already done, just a different type of regression. So we're going to stop for right now. We'll finish this up, and you'll have a worksheet to work on for that. In fact, I'm going to go ahead and give you the worksheet for after the quiz. You'll probably be able to do some of it without us even doing this last part right here. So let's put that away for now.